So we have 4 runners here in a 1-mile race: Maria, Aretha, Thelma, and Debbie, where points are awarded only to the women finishing first or second. First place gets more than second, where we want to see how many different arrangements of first and second place are possible. Where our goal, I'm not going to write this down this time because we've seen a couple examples, is going to be to put together the options for first and the remaining for second. Where to do that, there actually is a fairly simple counting method for this that we'll see near the end there, using a thing called either the fundamental counting principle or, in this case specifically, permutations, where you should get the answer there as 4 times 3 or 12. But just to be sure, what we can do here is make a diagram for ourselves where, because we have 4 racers, we have 4 options for first place. And then from each of those 4 options for first place, we then have 3 after that, because you can't be both first and second. That would be cheating, unfair, and very selfish. Also would bend the rules of reality, so obviously that doesn't happen. Where, if, for example, Aretha came in first, that would mean either Maria, Thelma, or Debbie could come in second. Where, again, we're not really making a distinction based on who we would expect to come in first and second, just who can. We're trying to describe all possible combinations, not necessarily the combinations that are most likely. One of them might be injured before the race, and so their combinations of first and second aren't particularly reasonable, but they are possible, so we'll count them. So each one of those 4 has 3 attached to it, and then you can count off all of the options there. Maria, Aretha, Maria, Thelma, Maria, Debbie, Aretha, Maria, Aretha, Thelma, Aretha, Debbie, Thelma, Maria, Thelma, Maria, Thelma, Maria, Thelma, Aretha, Anyway, those 3, then Debbie, Maria, Debbie, Aretha, and Debbie, Thelma, where very importantly, because first and second are different, because order matters, all of those are distinct, even though Debbie, Maria, and Maria, Debbie are the same pair. I think one of them would care which one came in first. So those are different things. Count those all off, and like we said earlier, we have 12 total options. That's not good. But anyway, this is essentially how we'd approach a problem like this. If you want to see it in a different way, like I said, you don't have to use the diagram, but that's probably the way I'd approach it, at least until we get more comfortable with the advanced counting methods that we're going to see later. And that's basically all we have here for Chapter 1. So let's move into Chapter 2, where we're going to start talking about sets.